So hello guys, today I'm going to show you how to generate a G code using SolidWorks CAM. So first of all, you have to open your step file or any uh, CAD file, and you have to convert it into SolidWorks Sketch. So the way to do that is to break link by selecting this option, yes. And then from here, we go to feature works and we recognize features. Now this will identify the shape and convert it into appropriate sketches in SolidWorks. So now you can see on the left, we have a SolidWorks sketch with extruded body. So from here, we can check the drawing itself, the sketch itself. Then from here you can see there's a rectangular line with a circular sketch. So from here, if you want to convert um, everything for linear interpolation, you have to convert this circular line into a several lines. So the way to do that is to segment this line by using segment function. So you can search on this top bar segment, then you choose how many points that you want to segment it. So sketch point, 10 point. So click OK. Now from here, you have to delete the original line, and then we use the line sketch to connect the dots. So like this. Yes. To ensure everything is closed and the body is in the gray color. So same thing in here, we do the same step. Use segment it, segment the line into 10 points. We delete the original circular line and we draw using line tool. Now same thing from here, we will also cover in segment, uh 10 points. We delete this, then we just connect dot. So same thing, we do it over here. Segment and segment, segment, and now we have everything in place. We just apply. Okay, so from here we have to activate the SolidWorks cam. So we go to add-ins. We tick SolidWorks cam to activate the add-in, and we click OK. Now SolidWorks cam has loaded. So first of all, we have to define machine. We click on the define machine, then we go to tool crib. We add our new tool. So this is where you put your electrode or tool size. Now for the type, we will go with flat end. We will put the diameter D1. Let's say in this case is 100 micron. One fluid, center cutting, and also shank diameter 0.1. Then we put some name, 100 micrometer tool. Then we click OK. Then from here, we set up the coordinate system. You can view it like this. So I like to put it here. This is how we will be our starting cutting position. Click OK. Then stock manager. No need to change anything. Click OK. And then set up mill setup. So here is the important step. First of all, this arrow showing where is your electrode coming from. So I want my electrode to be coming from the left side to the right side. So I will click this face. So you can see the arrow change to that direction. So I will click OK. Now we want to define the machining process. So we right click on the mill part. We go to 2.5 axis features. So here we can select what kind of machining that we wanted. So for this example, I will do in an open pocket machining. So and then we have to choose our entities. So we choose the back side of the body. So then we click end condition. Here we specify our end condition since we already picked the back side. Now we will select the front side up to face. Okay. Now we click OK. In this cam feature, so we right click on this, we go to 2.5 axis mill operation. We will do control millet. Now we choose our electrode, which is 0.1 flat end. We click OK. Now from here there will be a bunch of parameters. So this one we already defined. So we go to feed and speed, put operation, we put our spindle speed, and we put our feed rate here. For example, I will put 0.3 millimeters. And then in the control section, in the side parameters, I will put my cutting distance to be, let's say 1 mm. Single cut depth final is 1 mm, and then I will not allow any allowance. Okay. And then that parameter is how many distance that you want to cut. So in here, since my body is 1 mm and I want to cut only one time, so I will just put 1 mm. Okay, now we go to NC. So in this option, CNC compensation, we will select none, so that it will just cut the outer body. And then in lead in, this is where we select our initial point. So I will do start point, and I will click this line. And I will do start point. So you can see the black, the blue dot is on these edges. So this is my starting point. And then I will do perpendicular, then leading amount I will put 0, leading over I will put 10. And then in advanced, nothing, posting, nothing, optimize, nothing done, and you are set. Click OK, and then you can click generate toolpath, and you can see the green line that's showing your tool path. Now we can simulate tool path. You can see, I'll just rotate it a bit, and you can run and see how the tool is moving. You can see it is nicely going to the place that we want to cut it, and verify whether everything is in perfect uh, movement. Okay, so now we have confirmed. Then you can also use step through toolpath, this option here, to really see the movement type. You can see this here, it is rapid, and it will show linear also, and it can show also arc. So you can use this button to go one by one step, and you can see what kind of motion. So this linear. As I step through, you can see all the motion is in linear mode, linear interpolation. Okay, so once we confirm, we can generate this as a G code. You can press post process, and here we will select NC code, and we will put the name as let me just put this name left. Okay, I just say I will just save here, and this one post process window will come here. In here, you just click play, and it will generate the G code. So now you can verify all all of the movement is in the linear motion, and click OK, and the G code should be saved on your folder.